Alright, so in this problem, I have 16 to the power of x is equal to 32. So to solve this, well, I actually have multiple different methods. So my first method, I'm going to take the log on both sides. So I have log 16 to the power of x is equal to log 32. Now if I have something in the form log a to the power of b, I can move my exponent b to the front. So this is equal to b times log a. So for log 16 to the power of x, I can move x to the front. So now I have x times log 16, which is equal to log 32. Now I'm going to divide both sides by log 16. So these two cancel out, and I have x is equal to log 32 over log 16. Now log 32, that's the same thing as log 2 to the power of 5. Log 16, that's the same thing as log 2 to the power of 4. Now remember, if I have something in the form log a to the power of b, I can move my exponent to the front. So now I have 5 times log 2 over 4 times log 2. Now these two log 2's can cancel out, so I'm left with x equals 5 over 4. Now, for my second method, I have 16 to the power of x equals 32 again, and this time I'm going to rewrite 16 as 2 to the power of 4. So I have 2 to the power of 4 to the power of x is equal to 32. I'm going to rewrite as 2 to the power of 5. So now this is the same thing as 2 to the power of 4x is equal to 2 to the power of 5, meaning 4x is equal to 5, and x is equal to 5 over 4. So that is my second method. Alright, so in this problem, I have 40 to the power of 40 over 100 to the power of 20. So to solve this, I'm going to first rewrite 40 here as 2 times 20. So now I have 40 to the power of 2 times 20 over 100 to the power of 20. And this is the same thing as if I have something in the form a to the power of m to the power of n. This is the same thing as a to the power of m times n. So I have 40 to the power of 2 times 20, so this can be written as 40 to the power of 2 to the power of 20. Now I have this over 100 to the power of 20. And 40 to the power of 2, that's going to be 1600. So now I have 1600 to the power of 20 over 100 to the power of 20. And now if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of n. So 1600 to the power of 20 over 100 to the power of 20, that's going to be 1600 over 100 to the power of 20. And 1600 over 100, that's going to be 16. So I have 16 to the power of 20. And 16, that's the same thing as 4 to the power of 2. So I have 4 to the power of 2 to the power of 20, which is 4 to the power of 40. And now 4, this is the same thing as 2 to the power of 2. So now I have 2 to the power of 2 to the power of 40, which is equal to 2 to the power of 80. Now I actually have a second method of solving this problem. So again, I first start with 40 to the power of 40 over 100 to the power of 20. Now this time I'm going to rewrite 40 to the power of 40 as 40 to the power of 20 plus 20. Now I have this over 100 to the power of 20. And now this is the same thing as 40 to the power of 20 times 40 to the power of 20 over 100 to the power of 20, which is the same thing as 40 to the power of 20 times 40 to the power of 20 over 100 to the power of 20, which is equal to 40 to the power of 20 times 2 over 5 to the power of 20. And this is equal to 40 times 2 over 5 to the power of 20, 40 times 2 over 5, well, 40 times 2, that's 80, and 80 divided by 5 is 16, so I have 16 to the power of 20, which is equal to 2 to the power of 4 to the power of 20, which is equal to 2 to the power of 80. So that is my second method. Alright, so in this problem, I have 3 to the power of x plus 2 plus 9 to the power of x minus 1 is equal to 90. So to solve this, I'm going to first start by rewriting 9 as 3 to the power of 2. So now I have, this is a plus, 3 to the power of 2 to the power of x minus 1 is equal to 90. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is going to be 2 times x minus 1, which is 2x minus 2. Now, if I divide both sides by, well, first off, 90 here, this is equal to 3 to the power of 2 times 10, which 3 to the power of 2 is 9, 9 times 10 is 90. So now I'm going to divide both sides by 3 to the power of 2. So these two cancel out. And 3 to the power of x plus 2 over 3 to the power of 2, that's the same thing as 3 to the power of x plus 2 minus 2, plus 3 to the power of 2x minus 2 over 3 to the power of 2, that's the same thing as 3 to the power of 2x minus 2 minus 2, which is equal to 10. 2 and negative 2, these two cancel out, so I have 3 to the power of x plus 3 to the power of 2x minus 4 is equal to 10. Now, 3 to the power of 2x minus 4, that's the same thing as 3 to the power of 2x over 3 to the power of 4. And 3 to the power of 4 is 81, so I have 3 to the power of x plus 3 to the power of 2x over 81 is equal to 10. Now, I'm going to multiply both sides with 81. So now I'm going to have 81 times 3 to the power of x plus 3 to the power of 2x is equal to 810. Now 3 to the power of 2x, that's the same thing as 3 to the power of x to the power of 2. So I have this plus 3 to the power of x times 81 is equal to 810. And now I'm going to let the variable t equal 3 to the power of x. So now I have t squared plus 81t is equal to 810. Now if I subtract 810 on both sides, I get t squared plus 81t minus 810 is equal to 0. So now to solve this, we have to use the quadratic formula, and I'm not going to waste your time by actually doing that. But if you do use it, you should get that t is equal to 9, t is equal to negative 90. And now remember how we set t equals to 3 to the power of x. So meaning if t equals 9, then x is equal to 2. And if t equals negative 90, well, you can't take the power of a positive number and make it negative. So x equals 2 is my only solution. Alright, so in this video, I'm going to be solving the problem 2 to the power of 20 minus 1. So I want to find the value of 2 to the power of 20 minus 1. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2 is equal to 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 I can rewrite as 1 squared because 1 is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 squared. And the reason I put this in this form is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10, and b is equal to 1. So now I get 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now, 2 to the power of 10 is equal to 2 to the power of 5 plus 5, which is equal to 2 to the power of 5 times 2 to the power of 5, which is equal to 32 times 32, and 32 times 32 is 1024. So I get 1024 plus 1 times 1024 minus 1. Now 1024 plus 1 is 1025, and 1024 minus 1 is 1023. So now I have 1025 times 1023, and to solve this, or to multiply these two, I'm not just going to do it using the basic multiplication method because this takes way too long. Instead, what I'm going to do is I'm going to rewrite this as 1000 plus 25 times 1000 plus 23, and now I can distribute my 1000, so I get 1000 squared plus 23 times 1000, and now I can distribute 25, so I get 25 times 1000 plus 25 times 23. Now 1000 squared is equal to 1 million, so I have 1 million plus 23,000 plus 25,000 plus 25 times 23, which is 575. So now from here, 23,000 plus 25,000 is 48,000, and 48,000 plus 575 is 48,575, and that plus 1 million is 1,048,575. So this is my answer to this problem.